In your bookmark, what I'd like you to turn to is wherever you did, I think it's set 4A. 4A. And wherever you did questions 4 and 5 in set 4A. So for those of you who you've already submitted bookmark 3, I started to write this as a comment in reply to your bookmark as something to watch out for. But so many people were doing it, I realized it was probably because I hadn't taught it clearly. And it's been a while, like this was just revision for us, right? So I'm going to reteach this idea because it actually connects really well into inverse trig, okay? So we're looking at questions 4 and 5. Let's pick out one like, say, shall we go with 5? Because this is the one that, I think the last question there is the one that you want to help with. Okay. So I think it says this. Oh, wait, hold on a second. Yeah.
Wait, is this on?
Yeah, it's on.
Shout out to Daniel.
Daniel shout outs to himself. Okay, so there's the question, right? Now I think most of you, either by recognizing it or asking a friend, right? You noticed, even though you're like, it's half angle, right? But half angle is really the same as double angle, just in reverse, right? So we use this identity. Let's put it back in terms of double angle, okay? If I want cos theta in terms of cos thetas, okay? Rather than writing cos squared minus sine squared, I'll write it like this. Is that okay? Yes? So you rearrange a little bit, and eventually I think you get to this point, 1 plus. I think that's right, yeah? Now, here's the critical point where I want you to take notice, okay? Because at this line, yeah, I don't think I saw anyone who did it right, which is probably my fault, because I didn't mention it, but most people are going straight to here. They're saying, well, I'll take the square root of both sides, and this is what you get, and the value of cos theta, or cos x, or whatever, is given to you. So, oh, sorry, there should be a 2 there. 2? Yeah, that's right. Then you put in the number, and you get some fraction at the end, and you check your answer, and it's right. So you're like, great, I'll just move on, right? But there's a problem. What's the problem?
Didn't take the negative answer?
Yeah, that's right. I mean, just strictly speaking, from here to here, there ought to be a plus or minus there, right? So the plus is one of the answers, but we just sort of ignored the negative. Like, why do we ignore the negative? And why does the answer ignore the negative? Why is there only one solution there? Okay. So, bring it back over here, right? What this would be equal to if it's in terms of not 2 thetas and thetas, but x's and x on 2. You'll get plus or minus the square root of 1 minus 1 plus, sorry, cos x on 2. Okay, now, just like in measurement problems where you're trying to solve a quadratic, right? And then you get something at the end and it's 2 solutions, right? And there might be one that's negative. Okay, and you're like, well, it can't be negative, yeah, because it's a length or it's a time or something that I'm going to measure, okay? In exactly the same way, you can't just ignore the negative answer and just forget that it ever existed, okay? You need to recognize it and then justify why you can ignore it, okay? So I can say, yes, it's true that it is equal to this value, but the question is why. The question is why, okay? So, I want to give you a counter example, and you stop me when you can see where the justification is, okay? Let's try out, say, let's go back to here. How should I write it? No, we'll write this. We'll stay with this one. Okay. Let's take a value for x, okay? So let's say let x equal, say, 3 pi on 2. 3 pi on 2, right? Should that work? Yeah, that'll work. Okay. So cos of 3 pi on 2, what's that equal to? Cos of 3 pi on 2. What does cos do? It goes down and then it comes back up, right? So where's 3 pi on 2? It's okay, I'll draw it. Here we go. It goes down, comes back up. That's 2 pi, right? Halfway is pi. Where's 3 pi on 2? It's it's 1.5 pi, right? So it's between 1 and 2, so like Daniel was saying for the last 5 minutes, it's 0, okay? 0, no problems, okay? Now, if I were to follow through with this idea here, right, I would say cos of x on 2, which is 3 pi on 4. Okay. Now, I know I can evaluate that on its own, right, but I want to see what happens when I use this identity which I've just sort of come up with, right? It should be plus or minus the square root of 1 plus cos x, which in this case is 0, on 2, right? So simplify a little bit, you get this. Okay, now at this point, we clearly know something is wrong, right? Because cos 3 pi on 4, it's not a variable, it's an actual number. It's only got one value. And you can actually see where 3 pi on 4 is on this diagram, right? There's pi, that's pi on 2 there, so where's 3 pi on 4? It's halfway between those two, right? There's 3 pi on 4. Okay? So you can see this must be the negative one. It's minus 1 on root 2. Okay? So hold on a second. In this case, it's actually minus 1 on root 2. Because, you know, in this domain, from pi on 2 to 3 pi on 2, that implies that cos x is negative. Okay? So wait, in this case, I just took the negative one, and I had to disregard the positive. Whereas when most people solve this question, they did the exact reverse, and it seemed to work out. Okay? So my question is, how can you know either can I disregard the negative, like this, can I disregard the positive, like this, or in what cases can I not disregard either of them? Like I've got to keep both in check. Can anyone tell me? Go back to the question. Does it give you any clues? Right, okay, so coming back to this one here, right? You're given this domain, yes? So x has to be between 0 and 90, okay? Now, what that means is that cos of x on 2, if I just take this, right, divide everything through by 2, that means not only is x a cube, but it's between 0 and pi on 4. Okay, now come back to cos. Between 0 and pi on 4 is this kind of area in here, right? So cos of x on 2, whatever its value is, I don't know its exact value yet, it has to be positive, because in that domain it's positive, right? So here, the reason why I can get rid of one of the answers is I can say as cos x, sorry, I should say x, as I have this restriction, right? So therefore, cos x must be positive. Okay? So you have to include that. Just like if you were doing a quadratic, you'd have to say, I can disregard this negative because it's a length or a type or something that has to have positive value. Okay? Now, the important thing I want to get across is, like sometimes it'll be the negative that you disregard, right? So you need to start to get used to thinking about what angles you've got and whether it makes your final result once you process it through some trig functions or inverse trig function, whether you'll get something positive or negative at the other end. Okay, it's going to be really important for inverse trig because it just goes, it's not so clear cut as here. There's another step of abstraction. Okay, so we'll look at those tomorrow morning. But for now, all I want you to make sure is if I've handed your bookmark back to you, go back to the sections where you're answering questions like this. There's a few of them, okay? And make sure you include this line. It's vitally important. In fact, you may even like to write the line before this one here, because a lot of you just skipped it entirely. Okay, so go back, put it in another color, and yeah, make note of it. Thanks. Well, in this case, they just give it to you. Like they state it must be a cube. Strictly speaking, we actually can we can know a little more. We can say, if I want to take the positive square root, okay, I can have a bigger domain than being between 0 and pi and 2. I can actually be all the way from 0 to pi, right? Because then when I divide everything through by 2, x on 2 will be a cube, right? And therefore it's gonna cos of the acute angle will be positive, okay? But in this case they actually said, you know, this is data, so you know that's enough. They could have said it was less than pi, but they didn't.